Welcome back to Goliath. My name's Chris, and today I have with me another Chris.
Another Chris.
Yeah. Chris, can you introduce yourself, please?
Sure. I'm Chris Wilson. I've been working as a contractor with Goliath for, I guess, a couple months now, maybe just over a month. And started working with Chris and the rest of the team here on some of the reference designs that Goliath is trying to produce for some of the different industries that they're targeting.
That's right. Yeah. And so the first one that Chris has worked on here is the air quality monitor, which we are publishing about now. And so this is the video for it. So if you're watching this, you're probably reading about the air quality monitor. But it is also the first of our reference designs that has the Ostentus, which we have published about as well here. I'll give a little bit better view of it here. And so all of the underlying code. So Chris did all the Zephyr code underneath the hood here on the NRF 9160. It's got an air quality sensor, which, well, Chris will tell you about the hardware here, and it's using our new display here to showcase the readings that are coming off of it. And so we could kind of cycle through readings here. If people watched our Embedded World presentation, you would have probably seen that as well. So, Chris, what is actually under the hood? What did you put inside of this thing in this reference design?
Yeah, so this is using the new Aludel Mini kind of carrier baseboard system. So there's actually, Chris, if you can share my screen here, we can take a look at the block diagram.
Sure.
I can walk through some of this. Okay, cool. So so what's in the box here is an NRF 9160 featherboard from SparkFun. And that's connected to an Aludel mini carrier board that has a couple click headers on it. And those click headers have a micro weather clickboard and a micro HVAC clickboard. The weather board has a BME 280 weather sensor, so it measures temperature, humidity, and pressure. And then there's the HVAC clickboard, which has a CO2 sensor, and it has a header that you can plug in a particulate matter sensor from Sensoron. So there's an SPS 30 external particulate matter sensor that plugs into that board, and it gives you the ability to measure the particulate matter in the air.
Yeah, and I think that this is a common use case. We've seen this in office environments, we've seen this in forest fire monitoring, we've seen this in home environments. People want to know about the air quality, especially as with pollution's on the rise, as climate change is happening. People want to kind of understand what's out there. We use cellular because we've been using cellular in a lot of other reference designs. But when you think about connectivity, you don't want to necessarily be reliant on your Wi-Fi network. Maybe you are if you're in the home, but if you want to take this thing outside, get a little bit broader range of measurements there, you probably want to go a little further afield. Cellular's a great fit for that. What does it look like once? So you have this block diagram of the things that are inside the system. You're using Zephyr and NRF Connect SDK on the device. What does it look like then once you've published this air quality data to the cloud? What does it look like then?
Yeah, so we can check out, we're using Grafana here to hook up to the Goliath API and pull off all of the sensor readings that are coming back from the device. So you can see here we're measuring on the left-hand side. We've got the weather data streaming in using Goliath's LightDB stream database. And so we're pulling in the temperature, humidity, and pressure here, as well as the CO2 concentration. And then on the particulate matter side, we're pulling in the mass concentration and the number concentration. So that's all being graphed here in real time, streaming from the device over cellular.
Yeah, that's great. Yeah, and I think that often, we're showing this in kind of a shortened time span as well, right? We're saying like, oh, we want to look at the past 5 minutes, 10 minutes, 15 minutes, whatever. But really, a lot of times, when you think about the application space, usually the monitoring is happening over much longer time periods with large amounts of sleep in between.
Yeah, that's correct. Yeah, and especially the two sensors that we're using here, the CO2 sensor and the particulate matter sensor, they tend to have longer measurement cycles versus some of the other sensors that Goliath has used in their reference designs in the past. So, for example, the CO2 sensor takes about 5 seconds to complete the measurement cycle, and then the particulate matter sensor can be adjusted. So typically they recommend you take multiple samples and average those together in order to get a more accurate measurement. And so each sample takes a second to complete the sample cycle, and then usually you average about 30 seconds worth of samples together to make up the measurement that's showing up here in the Grafana dashboard. So those are adjustable, and we can actually get into one of the features of Goliath, which is the settings service, which will let you dynamically change those settings on the fly from the web dashboard versus having to hard code those settings into your firmware and recompile and push out a firmware update. So all of that's configurable using the settings service that Goliath provides.
Yeah, before we do that, I wanted to highlight another thing you have a little further down the page. You started doing some battery tracking as well.
Yeah,
Again, because if you're in this kind of, we're doing it kind of continuously, but if you're in a sleepy mode, another thing you want to do is you want to make sure you're waking up, you have sufficient battery. If not, maybe there's some other kind of problem, you want to send a technician out, that sort of thing.
yeah, totally right. So we're streaming in the battery data here. I have it plugged into USB, so this is just showing 100% battery because it's fully charged. But if we were running this demo on the battery power, you'd see the battery voltage and battery level over time being streamed back to the Grafana dashboard.
Yeah, that's great. So you talked about some of the update rates, how that's configurable. Maybe you could take us over to the Goliath console and show us where those settings are implemented.
Yeah, so if we pop over here, this is kind of the managing a device section of the Goliath console where you can manage all the devices in your fleet. And so if we look over here on the settings tab, you'll see that there's a bunch of different settings here that are configurable through the web interface. So we can take a look at some of these. For example, there's a CO2 sensor temperature offset. One thing that you can change here is if you deploy the device and your temperature readings are need to be adjusted or offset by a certain value, you can push in a 1 or 2 degree offset to get a more precise or accurate temperature reading. Similarly, there's also the ability to set things like the altitude where you deploy that sensor. So the CO2 sensor will take the altitude into account and give you better CO2 readings based on the known altitude where it's taking those readings at. So you could deploy the device, get it fully installed, and then push the altitude setting later on to get more precise readings from the device.
Yeah, and I think that kind of shows too, like just a general config. This is an arbitrary setting that you set up.
Yep.
It's not like something built in, so you can, as you start to analyze and need to optimize your sensors that you're working with, you can start to see how that might make a better system for your ultimate deployment.
Yeah, totally right. And you can see what we mentioned before about the trade-off between, like, for the particulate matter sensor, the number of samples versus the amount of time it takes, which translates into overall battery life for the device. If you need to adjust the number of samples that you're taking per measurement, there's a setting that I'm added here, which lets you set 5 samples per measurement or 30 samples per measurement. You can adjust that, and it will change the overall time it takes to take those measurements before the device goes back to sleep and shifts back into a low power mode.
So another thing that I wanted to bring up was the sensor and auto cleaning interval. So if you see something weird on your particulate matter, your readouts, and you're like, I really wish the reading would have triggered, you actually implemented a remote procedure call where you can just manually trigger that sort of thing. And I think this is a great example of remote procedure calls.
Yeah, this is one of the really cool features of Goliath that I have been playing around with. There's the ability to send a remote procedure call to the device. So we can send one here called Clean PM Sensor that basically issues a remote command that tells the device to clean the particulate matter sensor on demand. And so if we run the call method here, you'll see this sent off the RPC to the device. And that's going to kick the fan on the SPS30 sensor into high gear. It's going to try and clear out all of the particulate matter that's trapped in the device and hopefully give you more precise readings moving forward after cleaning everything out.
That's great. That's great. Yeah, and again, this is another arbitrary thing that you could have added any kind of function here, or you could also add parameters in there so that you could, say you wanted it to run for 30 seconds, you had some kind of subroutine on the actual device, you could actually pass that 30 seconds, 10 seconds, whatever it is, down to the device and use that as part of your command there.
Totally.
Another thing that's I think is great is the fact that, we're showing it here on the console, but this is also available on the REST API. So if you have a fleet of these things out there, you wanted to trigger them all to do a cleaning because for whatever reason, you could just go and individually run through each of your devices and trigger the remote procedure call.
Yeah, definitely.
You had started this from a template as well. Tell us a little bit about that.
Yeah, this was one of the reasons why we were able to get this reference design up and running so quickly. So I was able to go from basically not having worked with Goliath before to getting the reference design fully up and running in a couple weeks. We basically built the reference design on a couple templates that Chris and Mike had been working on here. So there's a reference design firmware template where kind of out of the box provides you with most of the settings and template code you need to connect to the Goliath system. And so really the only thing that I had to add was the customizations to add in the sensor readings and the sensor drivers to control the CO2 sensor and the particulate matter sensor. One of the nice things about the Goliath SDK being based on Zephyr is that the BME 280 sensor was already fully supported. So it was literally a couple lines of code, and that sensor was already sending readings back to the Goliath cloud. So the majority of the work was really just adding support for the CO2 sensor and the particulate matter sensor, and then getting those readings pushed back to Goliath. So it made it super easy. The other template that I used was a template for the Ostentis e-paper display. So Mike had provided this template library that lets you set up a slideshow on the e-paper and show sensor readings. So it was literally within an hour of getting that repository from him. I had sensor readings showing up on the display. So really super easy to get things up and running with the templates.
Yeah, and that is really all. That's all, Mike. That's I am a user of the templates as well. The thing that I like about it is that it's really re-implementing a lot of the stuff that's in the SDK. So things like RPC is broken out into its own .c and .h. It's very obvious that I want to go and add an RPC. I go and look at the example one that's there, replicate it, add all these new functions. Even things, and I think then we've been pushing some of that stuff back up into there too, like the one we published about with the changing the log levels. I feel like that's a really great template for people that are potentially interested in just utilizing the turning all your logs to the lowest level. So for like a cellular device like this, you get to save a lot of data, not just because of the CoAP and CBOR that we use natively, which saves data, but then also you're turning down all of your debug messages or your info messages or I only want to see errors, and that should be very rarely. So
yeah, it honestly felt pretty magical. My background is in hardware engineering, not software, and I've done some firmware stuff in the past, but the whole process of using the Goliath system and using the templates just kind of feels magical for a single hardware developer to be able to use the template, drop in a couple sensor drivers, write a little bit of code, and all of a sudden you have this device talking back over cellular, sending readings up to the cloud, and being able to see that in Grafana feels pretty magical.
Yeah, I feel the same. We are built on the backs of giants, that's for sure. Yeah. So this has been great, Chris. I think we're going to be doing more reference designs together, so I'm excited about that. Where should people find information about this design? Can you maybe point out the
so there's a project page on projects.goliath.io. If you go to projects.goliath.io, we can go here right now. If you go click on check out reference designs and then take a look at the air quality monitor, you'll see there's a project page here that has some photos of the device, block diagram. There's even a list of all of the parts that were used to build the reference design in case you're interested in building something similar yourself, and next steps. So if you'd like to kind of follow up and start taking a look at some of these reference designs, you can send an email to sales@goliath.io.
Awesome. Well, thank you for helping explain it here today. Thanks for building the design. I'm looking forward to the next one you build.
Yeah, thanks a lot.